Save some time. Calculator. All right, I think I got one more problem for you. Yeah, so we've got a rectangular page that is to contain 30 square inches of print. And there's a margin on each side that is 1 inch. I want to figure out the dimensions of the page so the least amount of paper is used. So I know I need 30 square inches of print, and I want a 1 inch margin. So how small can I make that paper? Okay, well, this is weird. All right, so let's try to visualize what's going on. I like to draw pictures. So I've got this paper. There's a piece of paper. And it's got 30 square inches of print with a 1 inch margin. So I'm going to kind of overdo this a little bit. But here's my print area. And then I've got 1 inch on all these sides. So there's 1 inch there and 1 inch here. 1 inch on every side. Great. Okay. And I know that the space inside of here is 30 inches squared. I don't know its dimensions. I don't know its length and width, but I know it's 30 inches squared in there. Did I write a 6? Why did I write a 6? Okay. All right. Well, and I want to know something about the area of the paper. So area of my paper is going to be length and width again. So here's my length, there's my width. So I want to know something about that stuff. Now I need to kind of like convert some of these things because I have the length and the width of the paper, and I also have the length and the width of the printing, because I know the length and the width in the printing. If I look at the printing, length times width there is going to be 30. And if I could relate that to the length and the width of the paper, then, oh man, we're going to be great. Well, we already know some stuff. If this is the width of my printing, I know that the width of my paper is going to be 2 more than that. So I know that that blue W equals, that blue W plus 2 equals the red W, the length of a paper. So you can do like paper, and then, I don't know, print, I don't know. As you can see, I wrote that wrong, and then I went down a rabbit hole of wrong, and I got all hot and bothered by it. So I'm going to try this again. I'm actually going to put the right variable there. How about I put a W instead of an L? Why I put a W, I have no idea. Then I want to do the same thing with the length. I know that the length is going to do the same thing that the width is doing. Is the length of our printing plus 2 is going to equal the length of the paper. So now I've got all of these equations. I'm going to put all these equations together in order to create one equation that is in terms of a single variable, is my goal for this optimization problem. So to do that, I got to pick somebody, and it doesn't really matter who you pick. You just got to pick someone. So Pikachu, I choose you. I'm going to choose this blue W. Reason I want to pick that one is because that's what I picked. So I want to pick one of the printing ones because I know more about the printing ones. I don't want to do the paper ones because then I wouldn't be able to have access to this equation. So I want to do one of the printing ones, and then I just like W's better than L's. So there. So I'm going to replace this W with a W plus 2, and that is going to be the width of the printing. So I've exchanged the width of the paper with the width of the printing. Now that L, I can convert it into, here, I need orange. So I've got that L, I've got it in terms of the printing L, but I don't want that. I want that to be the printing width. So that's where this other equation comes in. I can say that the printing length equals 30 divided by the printing width, and this variable is matching this variable. Nice. So I'm going to put this right here. So I get 30 over the printing W. I'll use brown so we know that it's the same variable. Plus 2 equals the length of the paper. Okay, so let's put that gobbledygook in there. So we've got 2 and then plus 30 over W. Close that off. And then A equals. Sweet, 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 sweet. All right, now we're ready to either start typing stuff into our calculator or do a little bit more work by hand. I want to do just a touch more work by hand. I want to FOIL that all together to make a nicer equation, just so that I can know I type it in my calculator right. So 30 over W times W is just going to be 30. I have to FOIL. So first outsides, so that's plus 60 over W. Insides, that's 2W plus outsides is 4. So my equation is going to be 34 plus 2W plus 60 over W. Sweet. Checking to make sure I got it right this time. Okay, now we want to figure out when the turnaround point is. Like, we want to minimize that thing. So when is, and you can see I've already graphed this over here. This thing is turning around, and you can kind of tell it's a little tough, but it is going up suddenly. So our paper area is going down, and then it suddenly comes up. And we want to figure out when is that suddenly. In order to figure out when that suddenly is, we need the derivative of this function. So we'll find A prime is going to be 2 plus, let's see, that's going to be negative 60 over W squared. We want to figure out when that thing equals 0. This one you could actually solve yourself. You don't need the calculator for. It is a calculator problem to save you time, but if somebody took your calculator away from you for some reason or another, you could come back to this one and you could solve it. I'm going to do that. So I'm going to get that 2 to the other side. So we get negative 60 over W squared equals negative 2. And then we get negative 60 equals negative 2W squared. And so then 30 equals W squared. And so W equals, and it would be plus or minus the square root of 30, but we know that, hey, you know, that width, it shouldn't be negative. It should just be positive. So our width is just going to be the square root of 30 inches. Using this, we can figure out what the width and length and width of the printing is. So remember, this is the width of our printing. So we know that this is the square root of 30. So what could the other side be? So what times the square root of 30 is 30? It's 30. So what times the square root of 30 is 30? It's the square root of 30. So L is also the square root of 30. But that's not what they were looking for. They wanted the paper's length and width. So the paper's width is, I think I put too many i's in there, is the square root of 30 plus 2, because we need to add in a margin, by, oh, plus 2 inches by square root of 30 plus 2 inches. Or they want it in decimals because it's nice to give both sometimes. 7.477 inches by, or about 7.477 inches. Calculator wouldn't have given us exact answer. We're super cool and we can figure it out for ourselves. Well, that's not exact, that's still rounded. Yeah, that's it. That one's kind of nasty. That one was kind of tricky. Just in general, to remind you about optimization, make a sketch. I can't stress it enough how important it is to make sketches. It really does help. It helps you create that primary equation. The primary equation isn't necessarily what you're going to take the derivative of. It just sets the stage so you know what you're trying to arrange, so you kind of have some buckets to put things into. Then you want to try to reduce it so you only have a single variable for these optimization problems. You want to try to get it down to just one. They'll be varied from time to time, so you kind of use your information that you've got. Keep in mind, any piece they give you, they gave it to you for a reason. So figure out where you need to put that. Determine the values for which the stated problem makes sense. Like I was talking about just a minute ago, negative square root of 30 makes no sense because I can't have a paper with a width of negative square root of 30. Can't do negatives. And then finally do your calculus. That's it for today. Thanks for watching. I think it's a little bit longer video, but maybe break it up or something. But yeah, thanks. Bye-bye.